Molting occurs when a larva matures in stages and needs to shed its old exoskeleton and secrete a new one, which is controlled by the endocrine system. Neurosecretory cells in the brain secrete prothoracicotropic hormone, which signals prothoracic gland to produce ecdysone. Ecdysone is produced in bursts, which trigger molt in process controlled by ecdysone. Ecdysone was also in charge of a process known as metamorphosis. Ecdysone can only change form until it is closer to adulthood if it receives a correct signal from prothoracic gland. The prothoracic gland can only signal if it has received a message from prothoracicotropic hormone. Juvenile hormone is secreted by a pair of endocrine glands, specifically from the corpora allata, and it works antagonistically against prothoracicotropic hormone. When a larva is about to turn into a moth, a high level of juvenile hormone is released, and juvenile hormone interacts with ecdysone, which causes the larva to grow in size and begin molting. So now, ecdysone and juvenile hormone have an antagonistic relationship, and the larva has to molt, the process that has to happen. Larva develops molds while still a juvenile because it has not yet undergone metamorphosis. It is still young. Eventually, after each molt, this growing moth will have a direct effect on the level of juvenile every time it molts, until it is very low, and the larva will have the opportunity to undergo metamorphosis. They can now transition into another form known as a pupa through metamorphosis because juvenile hormone levels are low. Pupas can continue to molt until they turn into adults through metamorphosis. And to get rid of those growing and reproducing insects, they use insecticides. Also, synthetic juvenile hormones stop adults from reproducing.
Created using Powtoon.